going to do a homework problem from homework 7. It's the exercise 7. So it says x, y are independent, identically distributed exponential random variables with parameter lambda, and we need to and z is given here. It's y over the maximum value of 2x and y, and we need to find the density function of fz. So first, I wrote down all the questions we are going to do on the blackboard, so we can save time writing it. The first step of it is to figure out what is the exponential random density function. So I wrote it down here. It's fx equals to the lambda times the exponential to the power of minus lambda times x. The only thing we have to notice here is that x has to be larger than 0 when it has the value. So now here we will get xy, the jointly function of xy, and the value will be lambda squared times e to the minus x plus y. It's still necessary to notice here only has values when x is larger than 0 and y is also larger than 0. So the graph would be very likely like this. Actually, there's no limit, but these parts only parts has the values. So the second step of it is to find out the values of y. I wrote it down here. So it has two cases. The first case is is when 2x is larger than y. So we'll get y over 2x. And the other case is the y when y is the larger value, and we'll get y over y, which gives us y equals to 1, and y is larger. So we'll have another two cases when we try to calculate the density function. When z equals 1, so it's the same case as 2x less than y, and so showing on the graph here, we can see that this is the part we are going to do the integral in this question. So we do the integral for x from 0 to 2y, and then for y from 0 to infinity. So I just wrote it down here. This would be the expansion of it, and so this one is the integral of e lambda x. So let me write it down again. So when we do the integral of e, this one, what it would be is like this. So this is basically the calculation. I'm not going to talk about more of it. As you can see, it's just on the screen. So another thing we need to notice here is that this value is not the distribution function, because it's given z equals to 1. It's kind of like the discrete functions, discrete time functions, because like when you have a pulse, it's like the possibility of the points. So the second part of it is to do the integral of this area. So because y is smaller than 2x, so this z value has to be smaller than 1. So the graph would be like this. It cannot be like overpass the y equals 2x. And this time it should be the distribution function, because the the z value here is smaller than z. This is the definition of the random variables, and the calculation is like almost the same, just the upper limit is different, and the final result will be here. So we have to do an integral here to calculate the density function for fzz, and it would be like this over minus a derivative of the bottom one times the top one. So the final answer is given here. As you can see, when z is from 0 to 1, yeah, it will be like 1 times 2 over 1 plus 2z squared. And when z equals 1, the value will be exactly 1 over 3. So the graph is showing here. This is the pulse I just mentioned here because it's given as p z equals 1, which is like the discrete time function. And hope you guys found it helpful.